Hey guys, this is CHEMPLIFIED and in this video we will talk about Clemmensen reduction. This is a reduction reaction from the topic aldehydes and ketones because we will be reducing aldehydes and ketone using Clemmensen reduction. This is the first named reaction from aldehydes and ketones. There are 5 or 6 more named reaction that we will talk about. So let's start with the first Clemmensen reduction. Now, in this reaction, it simply states that an aldehyde or ketone, when treated with zinc amalgam in presence of HCl, gives alkane. So this is your reactant. In place of R dash, you can put hydrogen also, so that this will create your aldehyde. Now we have taken the example of ketone, but we can choose aldehyde and ketone, anyone. Now, in presence of zinc amalgam, means alloy of mercury with some other metal, and HCl is also present. Now, what this will give you as product is alkane, R C H R dash. This is your Clemmensen reduction. We will talk about the mechanism also, but before we go for the mechanism, just remember a few things. HCl and zinc amalgam are present in the reaction. We are using zinc amalgam and HCl. So don't forget that we don't have only one molecule of HCl. This is a reaction. We have a lot of molecules of HCl, which means we have a lot of ions of H plus and Cl minus. The quantity of ions of H plus and Cl minus in the reaction is really large, and we will use this according to our need. All right. Similarly, zinc is also present. In large amount, and we will use this zinc as our necessity. There are a few properties also that you should remember. Here H plus ion will act as cation or electrophile, and Cl minus will act as nucleophile. Similarly, zinc has the ability to donate a lone pair of electron. So zinc here will act as nucleophile. These are the few things that you should remember before we go for the mechanism. So let's start the mechanism now. Let's start with our reactant. This is our reactant. Don't worry about R and R dash, because everything that is going to take place in this mechanism will be taking place at this carbon, right? So don't worry about R and R dash. Now first what will happen is H plus will attack the oxygen atom. Why? Because oxygen has electron lone pair. So H plus will attack the oxygen, and since carbon and oxygen are polar in nature, so carbon will have delta positive charge and this one will have negative charge, right? So H plus will attack the oxygen atom, creating a carbocation like this, and there is a positive charge, right? Now what happens next is, now comes the zinc. Zinc has a lone pair of electron, and this lone pair will attack the carbon, right? And it will give you and OH. Now since, wait a second, since zinc has already donated its lone pair of electron, so zinc will now carry a positive charge, right? I will try to change the color in every possible step. Now what happens is, there comes chlorine, Cl minus. Now chlorine has a lone pair of electron. This lone pair of electron will now attack zinc, and it will give you another product. Sorry, and there is also H plus, and this H plus will attack the oxygen, because oxygen has another lone pair. So in this particular step, two things will happen, and you will get the patient C R dash Zn Cl HOH positive. The oxygen will now have a positive charge, and to neutralize this positive charge, this particular bond will break and the electrons will move to oxygen, right? So in the next step, what happens is, in the next step, what will happen? H2O will be removed. H2O will be removed, and you will get R, C, R dash, ZnCl, and so let me draw it again. Since H2O is removed, we have space. We will get R, R dash, and ZnCl, right, with a positive charge on the carbon, right? Now what happens in the next step? Let me change the color. Now what happens in the next step? Zinc will again attack something. What is it that zinc is going to attack? I am writing this intermediate in the next step also. You will get R, C, R dash, R dash, ZnCl, right? This zinc will now attack. Remember, this zinc will, the electrons will attack the chlorine, and these ZnCl bond electrons will move towards zinc, right? Let me move it a little bit. Now what happens next is, ZnCl will be removed, right? And you will get a product as follows: R, C, R dash, Zn, and this time zinc will have a negative charge on it. That means a lone pair of electron will be there. Now in the same step, let me remove it a little bit more. Now in the same step, the electrons on the zinc will attack, or transfer of electrons will take place from zinc to carbon. The electrons present on zinc will be transferred to carbon because carbon is now have a positive charge on it, right? Carbocation was created. Now what will happen in the next step? In the next step, carbocation will be converted into carboanion. You will get R, C, R dash, zinc, and a negative charge on carbon, right? Now in the next step, the H plus will now attack the carbanion, right? And you will get, look at the product, R dash, H, and zinc, right? I hope you understood this much. Now what happens next? Let me first, now what happens next is, there comes Cl negative. Cl negative, that has 2 electrons. This will attack your zinc, and the electrons present in carbon and zinc bond will be transferred to carbon again, and you will get R dash and H with a negative charge on this carbon, right? Plus ZnCl. ZnCl will be removed, and in the next step, what happens is, again another H plus will be there, that will attack the carbanion. Carbon has a negative charge, so this will attack the carbon, and you will get the final product, your alkane. R, C, R dash, H, and H. This is your alkane, So this was your complete mechanism. Let me show it one more time in 5 seconds. So first step, H plus will be transferred. Let me change the color. Let me take a different color this time. This is all right. In the first step, what you did is H plus transfer. Now the electron, you created a carbocation because the electrons present on the double bond were transferred to oxygen, right? Now the zinc electrons were transferred to carbocation, creating these 4 different bonds. The chlorine minus now attack the zinc, creating ZnCl. Now H2O will be removed in the next step. After removal of H2O, again carbocation will be created. This carbocation is then remain as it is. First, zinc will attack the chlorine molecule present in the previous intermediate, taking out ZnCl and creating a carbon zinc bond and a carbocation. Right? Now, what happens next? After removal of ZnCl, the electrons present on zinc are transferred to the carbocation, giving that carbocation a negative charge. That negative charge will be attacked by H plus ion, and then this molecule is complete. Carbon has all its valencies complete. Now the bond between zinc and carbon will get broken, and the electrons will be transferred to carbon, creating a carbon ion again. Right? After the creation of carbon ion, H plus will attack again the H plus will now attack the carbon and will create your final product alkene. I hope you understood the mechanism. If you want to follow all the steps, you can rewind the video. You can go back in the video and watch the complete mechanism. Right? So I hope you understood the mechanism. This will be it for today's video. This was your Clemmensen reduction for the production of alkanes. Thank you very much for watching.